All right, guys, we're going to begin chapter 8. Chapter 8 is all about confidence intervals. So we're really heading into the heart of statistics when we're starting with this chapter here. We're going into what's called inferential statistics, and that's all about confidence intervals and significance testing. And it's really some of the most important and I think some of the most interesting stuff in all of statistics. And at the end of any type of research study, any type of experiment, it almost always ends with a confidence interval or a significance test. So this is really, really important stuff. And again, like I said, I think it's really interesting stuff as well. So let's get into it. So how is this different than in chapter 7? So in chapter 7, we pretend to know what the true population parameter is, what the true mean value is, what the true proportion is, and then we ask questions about our X bar, our sample mean, or our p hat value. But that's not really realistic, okay? In chapter 7, we were saying, okay, assuming that 70% of people believe in ghosts, what is the probability when you take a sample of 100 that less than 60% are going to believe in ghosts or something like that? That's not really realistic in terms of what we see in the real world. What happens in the real world is we begin with sample data. Okay, so we begin with a sample mean X bar or a sample percentage P hat, and then we use that X bar or that P hat to kind of make an inference or a prediction about what the actual value is for our entire population. So this is all about collecting the data first, getting that sample statistic, that X bar and that P hat, and then using that to then make an inference about the overall population. So within that, we have this thing that's called a point estimate. A point estimate is our single best guess for the value of the population parameter. It's almost certainly going to be a little bit off, and it's not likely to be perfect. So our solution to this is that we use an interval of values based off of that point estimate. So the point estimate is our best guess. It's going to be our sample mean, our X bar, or our sample proportion, our P hat. That's what we're going to use. That's going to be at the center of our interval to create that estimate for what the actual value is for our population mean or our population proportion. So your point estimate is just a fancy name for either your X bar or your P hat. So what is a confidence interval? A confidence interval is an interval of plausible values for the population parameter. So it's our interval that's saying, okay, we're blank percent sure that the actual mean or the actual proportion is somewhere between this and this. So to create that confidence interval, it has two parts. It has your point estimate, which is either your X bar or your P hat, plus or minus the margin of error. And you see this a ton when we're talking about polling, right? When you talk about polling, they've actually created a confidence interval, which they never really talk about. But that's a lot of what you see in polling. We have that thing, which we've talked about previously in the year, with that margin of error. So what is the margin of error? The margin of error is how far we expect the sample statistic, aka your X bar or P hat, to vary from the actual population parameter at most. So it's the largest amount that we think that our sample statistic could vary. And it gives us that leeway as a part of our estimate. The margin of error has nothing to do with any type of bias. It just has to do with the fact that when you're taking a sample, there's going to be some amount of variability, some amount of error when we take that sample of, say, size 100 and try to use that to estimate for a much larger population. When we are interpreting a confidence interval, okay, we're always going to use the same basic sentence. So it's important that you know this sentence, and it's kind of going to be ingrained in your memory. Lots and lots of times you're going to be asked to interpret a confidence interval, okay? And how do we do that? Well, we use this sentence. It's always going to start with something like, we are blank percent confident. And the percentage of confidence will be given to you in terms of a confidence level. Lots of times we use 95% confident. So we are blank percent confident that the interval from whatever you get as a part of your interval, from blank to blank, captures and this part is crucial, the true population or the actual population. And then our parameter in context, whatever we're talking about. Maybe we're talking about the average number of shoes people own. So we are 95% confident that the interval from 9.3 to 17.4 captures the true population mean number of shoes a high school student owns, something like that. Or maybe it's a proportion, captures the true population proportion of people who are going to vote for a certain candidate, whatever it may be. But that's your parameter in context. And it could be proportions or it could be means, okay, depending on what type of question that we're asked. We've got an example at the top of the next page. We'll go through that example in class, as well as example number 2 in class as well. So what is the formula for calculating a confidence interval? We've kind of talked about this. All right, it is our point estimate plus or minus our margin of error. On the formula sheet, you will see it written as confidence interval and then statistic plus or minus the critical value times the standard error of the statistic. So this portion in here, this thing which is called a critical value, which we're going to talk about, times the standard error of the statistic, that's your margin of error right in there. And this is on the formula sheet. If we take a look at the formula sheet, okay, lots of stuff on here. But if we look right in here, confidence interval, statistic plus or minus critical value times the standard error of the statistic. And as we go later on, you'll see the formula for standard error of the statistics will also be given to you as we get into actually calculating this confidence intervals later on. So, how can we reduce the margin of error in a confidence interval? Why do we want a small margin of error? And are there any drawbacks to that? Well, there's 2 major ways that we can reduce the margin of error. We can reduce the confidence level, okay? Meaning we can go from 99% confidence to 95% to 90% to 80%. So reducing the confidence level will shrink the margin of error and will shrink the actual interval size. So for example, we might be 99% confident that the mean is from 80 to 100, but we're only 80% confident that it's from 88 to 92 or something like that. Okay, so as you reduce the confidence level, your margin of error shrinks and your interval shrinks. Another way that we can reduce the margin of error is to increase the sample size. Okay, both of these things will allow for a more precise estimate. All right, we want to shrink down that interval size. Okay, so we want to shrink that margin of error. We don't want to create an interval that says we are 99% confident that the actual mean is between 50 and 500. That's huge. Or we are 99% confident that the actual percentage that are going to vote for this candidate is from 35% to 70%. We want to shrink that margin of error and that interval down to create a more precise estimate. Another drawback of this, though, is that it's less likely to capture the actual population parameter since the interval is narrower. Okay, as we decrease the width of that interval, we reduce the margin of error, it's less likely that we're going to actually capture what that actual true mean or proportion value is. 2 important things to remember when constructing and interpreting intervals. First of all, we have to assume that the data comes from a simple random sample or that it's obtained randomly. Reason being, we're trying to use that sample to estimate for the entire population. So that sample needs to be representative of the population. In order for that to be true, we have to be taking from a random sample. Secondly, the margin of error only accounts for chance variation that will occur from random assignment or random samples. It does not account for error from bad research or study designs. So margin of error has nothing to do with any potential biases that might be based on the sample design or how you've conducted your study. It only has to do with the fact that we're taking a sample, there's going to be sampling variability when we're using that to try to estimate for the entire population. We'll look at this example in class, but the key thing for you to understand here is that whole concept of a confidence interval. So remember, we're going out, we're collecting sample data, we're getting a statistic, either a p-hat if it's a proportion or an x-bar if it's a mean. Then we're using that proportion or that sample mean to now make an estimate for what the actual mean is or what the actual proportion is for the entire population. That's what inferential statistics is, making that inference, jumping from that sample data that we've collected to make a prediction for the entire population. Lots of interesting stuff. We'll look at lots of examples. We'll collect our own data. I'll see you in class.